Welcome to Chapter 3. We're in Section 3.1.1 today, and it says, what does an exponential graph look like? Now, we've seen these graphs before. We're investigating functions in the form of y equals b to the x. Now, it's very similar to our sequences that we had that were geometric. These are exponential graphs for the function, geometric for the sequence. So we're going to be looking at graphing, identifying the domain, range, and intercepts. So for problem number 1, we're going to make a table of values. Now, in our table, we're going to include some positives, some negatives, and 0. So we have -2, -1, 0, 1, 2, 3. So when x, so it's 2 to the negative second, that means reciprocal. So it's 1 over 2 squared, which is 1/4. 2 to the negative first is 1 over 2 to the negative first, which is 1/2. 2 to the 0 is 1. 2 to the first is 2. 2 squared is 4, and 2 to the third is 8. So we have 1/4, 1/2, 1, 2, 4, and 8. Now, if we were to graph this on the calculator, you'll see that no matter what the smallest value for x is, if we go into the negative direction, we're never going to get to 0. So these graphs have a horizontal asymptote. And this horizontal asymptote is at y equals 0. So we draw our graph. We get very close to that asymptote, but we never cross it. And there is our graph. So our domain, any value for x we want to, all real numbers. Our range, y is greater than 0. Our horizontal asymptote, I'm going to use the abbreviation HA from now on for that. Y equals 0. It's that horizontal line. Now, our x-intercept. We never cross the x-axis, so there is none. And our y-intercept, we can see when x is 0, y is 1. So it's going to be at 0, 1. There's our graph for 2 to the x. We'll do the same thing for 4 to the x. Making a table. -2, -1, 0, 1, and 2. So it's 4 to the negative second, which is 1 over 4 squared, which is 1/16. 4 to the negative first is 1 over 4 to the first, which is 1/4. 4 to the 0 is 1. 4 to the first is 4, and 4 squared is 16. So it grows much faster than the last one. So we're at 1/16, 1/4, 1, 4, and 16 is way off the graph. Once again, we have a horizontal asymptote. These exponential functions have horizontal asymptotes. This one's at y equals 0. When you draw your graph, don't cross that asymptote, and it grows very fast once you get past that. So our domain, we can use any input we want to. It's all real numbers. Our range, y is greater than 0. Our horizontal asymptote, HA for short, is at y equals 0. Our x-intercept, this one doesn't have any. It never crosses the x-axis. And our y-intercept, it crosses the x-axis at 0, 1. Now, for number 3, it's a little bit different because we have a 1/2 in the parentheses. So let's see what happens when we have a fraction less than 1 being raised to the power. So we have -2. So it's 1/2 to the negative second. So we're going to take the reciprocal of everything inside. So it's 2 squared, which is 4. 1/2 to the negative first is 1/2. 1/2 to the 0 is 1. 1/2 to the first is 1/2. And 1/2 squared is 1/4. So now we're here at -2/4. I'm sorry, I made a mistake. 1/2 to the negative first, that's 2. Excuse me. Or 1, 1/2, 1/4. So we still have that horizontal asymptote, except now it's falling from left to right. And there's our graph. Our domain, still all real numbers. Our range, y is greater than 0. Our horizontal asymptote, HA for short, is at y equals 0. X-intercept, it still doesn't have an x-intercept, so there is none. And our y-intercept is at 0, 1. So a lot of similarities between the graphs. The only difference is for that 1/2, it's falling from left to right. Let's see another one on the next page. 1/4 to the x. -2, -1, 0, 1, and 2. So it's 1/2 to the negative second, which is 4 to the second, which is 16. 1/4 to the negative first is 4 to the first, which is 4. 1/4 to the power of 0 is 1. 1/4 to the first is 1/4. And 1/4 squared is 1 over 16. So 16 is way off the graph. We're at 4, 1, 1/4, 1/16. So you can see this falls really fast. There's still that horizontal asymptote at y equals 0. So when you draw our graph, it's going to fall sharply and then turn and then never cross that line y equals 0. Domain, still the same thing, all real numbers. Our range, y is greater than 0. Our horizontal asymptote, HA for short, is at y equals 0. Our x-intercept, there still is none. And our y-intercept is at 0, 1. Hopefully you're starting to recognize those similarities and differences in these graphs. Now we have a couple strange ones. -1 to the x. -2, -1, 0, 1, and 2. -1 to the negative second is 1. -1 to the negative first is -1. -1 to the 0 is 1. -1 to the first is -1, and -1 squared is +1. So what's happening here is we're at -2, 1, -1, -1, 0, 1, 0. And what's going to happen is it's going to keep bouncing back and forth between -1 and 1. Now, we cannot connect these with reasons that we're going to be learning later on in the year, with square roots and even roots for that matter. So what this graph is, it's discrete. It's not continuous. That's what the graph looks like. And if you graph this on your calculators, you'll see that this is the graph for it. 0 to the x. Now, we can't have 0 to the 0. You're going to get an error. It doesn't exist for our purposes. And 0 to the negative first, it's a little out of order, is also going to give you an error. You can't raise it to the negative first power because that's reciprocal. It's 1 over 0, which would be undefined. So then when we get to 1, 0 to the first is 0. 2, it's 0. 3, it's 0. So what the graph would look like, there'd be an open dot at 0, and it's going to go like that. That's what the graph of y equals 0 to the x looks like. Now, the reason I included those last two graphs is when you notice for y equals b to the x, when b is greater than 1, if you look at our first two problems, when b is greater than 1, it's growth. It grows from left to right. When b is between 0 and 1, it's decay. It falls from left to right. If you notice with those values, b cannot equal 0 and b cannot equal 1 because then it doesn't operate in that exponential function. It doesn't grow or decay, and they're not continuous. So that's why b is greater than 1 or b is between 0 and 1, never including 0 or 1 in your values. We're going to finish up this part with some general characteristics on the next page. For exponential growth, remember it's in that form of y equals b to the x, where b is greater than 1. They're going to have this basic shape to it. They're going to have a horizontal asymptote at y equals 0. The domain is going to be all real numbers. The range, y is greater than 0. For the x-intercept, there is none. And for the y-intercept, it's going to be at 0 and 1. Those are characteristics that all of these exponential growth graphs in the form of y equals b to the x will have. For exponential decay, y equals b to the x still, where b is between 0 and 1. So you're going to see a graph that looks like this. It's going to fall from left to right. So the horizontal asymptote is going to be at y equals 0. The domain is going to be all real numbers. The range, y is greater than 0. The x-intercept, there will be none. And the y-intercept is going to be at 0, 1. Those are for when you're in the form of y equals b to the x. We'll be expanding on that and adding some extra pieces to that equation in the coming sections. Thank you, and I'll see you for the next part of this video.